In this video, I'm going to tell you about the integration of combination of trigonometrical functions. So there are certain trigonometrical functions that we get upon differentiating tan, cot, cosec, or sec. On differentiating tan x, we get sec square x. On differentiating sec x, we get sec x tan x. On differentiating cot x, we get minus cosec square x. And finally, on differentiating cosec x, we get minus cosec x cot x. So like in the first video, I had told you that integration is the exact opposite of differentiation. So that's exactly what we're going to use here when we integrate each of these. This was the differentiation of sec square x, so we get of tan x, so we get tan x plus c. The second one was a differentiation of sec x. So obviously we get sec x plus c. The third one was the differentiation of cot x. So yeah, you guessed it right. We get cot x plus c. And lastly, we had minus cosec x cot x. On differentiating this, we get cosec x plus c. Now you might be wondering why I haven't spoke about how to differentiate simple trigonometrical functions like tan x or cot x. So that's because when we integrate, we don't have the option to integrate the function as a whole. We have to break it down into its component functions. So we have to break down tan into sine by cos, or cot into cos by sine, and then using the formula which I mentioned in the last video, we get the answers. So let's do tan x and cot x in this video. So we have tan x here to be integrated. Tan x can be written as sine x by cos x dx. Now in the fundamental formulas, there are no methods to differentiate this entire expression by itself. So what we have to do is use a new method called substitution. So we take another variable, let's say z, and we take cos x to be z. So on differentiating z, we get dz is equal to minus sin x dx. And so what we have here is minus 1 dz divided by z. So you see it's exactly like the inverse formula over here. The minus comes out of the integration because it's the sign of the function, so it won't be involved in the integration. So the answer here will be minus log of mod z plus c, which is basically the negative of the log of cos x plus c. Or we can also write it as the log of sec x plus c. I use the basic logarithmic function over here. Cos x is 1 by sec x, so minus log cos x is equal to plus log sec x. Let's integrate cot x now, shall we? So cot x can be written as cos x divided by sin x, and it's the same case as tan. This expression cannot be integrated on its own. We have to use substitution. Substitution is a very important part of integration, and if we understand how it works, we can use it in almost any case and make the integration like a lot easier. So yeah, this comes to, we'll take a variable, say y. We can take any variable. Let's take y. Y is equal to sin x. So the differentiation of this equation is dy is equal to cos x dx. And so we have it here. We replace sin x with y, and cos x dx, the function in the numerator, is replaced with dy. So we have dy by y, which is the log of mod y plus c. Now this is basically, since we substituted y is equal to sin x, we put it back, we put sin x back, so we get the log of the mod of sin x plus c. This is the integration of cot x. It can also be written as the minus of log cos x, since sin x is it's 1 by cos x. So cosec x. So it can be written as the log of mod cosec x with a negative sign in the beginning. So that's it for this video.